Okay, welcome back to part 3, the final installment on transformations of graphs. We're going to start with question 16, although I guess the questions are never really consistent, other there's two question 14s and a whole bunch of other things. Anyway, this one is question 16. Again, I'm going to insist on putting it in the way that I like to see it, because otherwise I can't do these things in my head. Maybe you can, but I just find I really struggle with them. So I'm going to switch these two around. The negative belongs to the 3 on 1 minus x, and there's an invisible positive in front of the 2 there, so that's the plus 2. Negative 3 on, and I don't like to draw 1 minus x, I always like to draw x minus or x plus something. So I'm going to drag out a common factor of negative 1, even though it's not common, but anyway. That means that I've got negative out the front, and then x minus 1. I guess some people might argue, well, at this point you could probably just cancel these two negatives, which is true, but let me just leave them there for the moment. So this one is going to be a dilation by a factor of 3 from the x-axis. It's going to be a reflection in the x and y-axis, and it's going to be a translation of 1 unit right and 2 units up. Okay, so for this, the domain is going to be all real numbers except for 1, and the range is going to be all real numbers except for 2. Okay, now as you can see, the dotted line's the original and the dark line is the new graph. It's been reflected in both axes, which means it actually kind of, it works out to be exactly the same as what it was originally, the same sort of shape. That's not always true for all graphs, but it is true for a lot of them. So this one ends up being the same thing in the end. Let's have a look at this next graph. Negative square root 3 minus x plus 4. Again, I'm going to put it in the format that I like it. Negative square root negative, took out the negative as a common factor, x minus 3 plus 4. So there's no dilations in this case. It's a reflection in the x and y, reflection in the x and y axes. It's a translation of 3 units right and 4 units down. So it's a square root function, so the domain will be from negative infinity all the way up to 3, and including 3 actually, because you can get the square root of 0, and the range will be from, good question, negative infinity all the way up to and including 4 as well. Okay, so reflection in the x and y axes. This time it doesn't go back to what it was originally. It was only true for the previous question, and others like it, but not like this one. So I think this is the final question that we're going to have a look at. Again, I'm going to insist on putting it the way that I like it, because I can't see these things. It's too tricky for me to understand all in my head. So the half out the front can be left there. I'm going to take 1 on 3 out as a common factor in this case, so it'll be then x minus, and then 3 divided by a third is 9, all to the power of 4 plus 1. So it's dilated by a factor of a half from the x-axis, and I need to do this twice, dilation by a factor of 3 from the y-axis. Okay, and it's a translation of 9 units right. How do you spell right these days? 9 units right and 1 unit up. Now the domain for this graph is going to be all real numbers, and the range is going to be from the minimum all the way up to the maximum, with the maximum being infinity. The minimum looks like it's going to be from and including 1 all the way up to infinity. Okay, now again, this could be written as just one dilation factor. It could have been 1 on 2 times 1 on 3 all to the power of 4. Take it out of the square root sign. And then you still, sorry, not square root sign, take it out of the power sign. You still got that, all that to the power of 4. And then that would be 1 on 2 times 1 on 81, I believe it is. So it's 1 on 162. That's the dilation factor. But we can have it as 2 different dilation factors if we want to. So that sums up all of those questions. And hopefully you're now a little bit more confident with dilations, reflections and translations. Make sure that you also know the matrices format as well, because they are starting to use that a lot more in exams. So if you've got any more questions, please ask one of your teachers, but that should be it for this.